Question 10 of paper 1 for June 2024. It reads as follows. EHGF is a rectangle. HE is produced x squared centimeters to n. That means that the distance from the line HE to n is x squared, and EH is produced x squared centimeters to p. So the line EH, the distance between H and P, is also x squared units. NF produced intersects PG produced at M. So simply what they are saying is that if you extend NF and you extend PG, that they meet at M. And this forms an isosceles triangle MNP. So this is our isosceles triangle with NM equal to MP. D lies on NP in such a way that it's perpendicular to NP. NP is equals to 4 units, so the full length of N to P is 4 units, and MD, the perpendicular height, is 3 units or 3 centimeters. 10.1. Show that the area of the rectangle is given by AX equals to 6x squared minus 3x to the power of 4. So for question 10.1, we need to find the area of a rectangle, which is simply the length times the breadth. Or I can say the length is EH times the breadth of FE. So let's see if we have enough information to find EH. EH is part of this line in P, so I can see that the length of EH is equals to 4, which is the full length of NP, minus x squared minus x squared. And that simplifies to 4 minus 2x squared. So we have the length of EH. Next, we need to find FE in terms of H. We are given that in this triangle, or that perpendicular height is equal to 3, and we know that this is a rectangle. So that means that the line of FG is parallel to the line of NP. We also know that the rectangle has 90 degrees here, so therefore the line of FE is parallel to GH, but that also makes it parallel to MD. So what I can see is that forms two different triangles. We have a smaller triangle, NFE, and we have a bigger triangle, NMD. And I need to go beyond paper 1 here to solve this, because I can see I would need to prove similarity. But because this is paper 1, you don't have to worry about proving similarity. Let's just write it down simply. If I look at our two triangles, which is triangle NFE and triangle NMD, I can see that N is our common angle, so that's common. Angle E would be equals to angle D, so that is 90 degrees. So I can focus, or I can group E with D, and angle F would be equal to angle M, our third angle. So therefore we can say that triangle NFE is similar to triangle NMD. And what that helps me to do is to create a ratio. So we want to find FE. So FE is grouped with MD. So FE over MD is equal to, and let's use the x squared. So that's NE. NE is working with N of D. So NE and ND. So I want to find FE. I know that MD is equals to 3 units. So you can see MD is 3. NE is equals to x squared. And N of D, or ND, would be 2 units, because this is cutting this in half. So that is 2. So that is 2. Therefore, FE is 3x squared over 2. So I simply cross multiply. It's a little bit complicated for the solution, but let's see. So the area of the rectangle is EF times FE. So we have EF as 4 minus 2x squared multiplied with 3x squared over 2. Now let us expand that quickly. So we have 4 times 3, which is 12x squared over 2, minus 2 times 3, which is 6x to the power of 4 over 2. So can you see it's 4 times this fraction becomes 12x squared over 2, and negative 2x squared times this fraction becomes negative 6x to the power of 4 divided by 2. And therefore, the area, when I simplify, is 6x squared minus 3x to the power of 4. And that is the area which they asked me to prove. 10.2. Calculate the maximum area of rectangle EFGH. So they gave us the area of the rectangle, and that area is 6x squared minus 3x to the power of 4. Now for the maximum area, I need to take the derivative of the area and set that equal to 0. So the derivative is 12x minus 12x cubed. And when I set that equal to 0, I have 12x minus 12x cubed. And I can factorize out a 12x. So I'm left with 1 minus x squared. And when I factorize further, I have 12x equals to 1 minus x and 1 plus x. And when I factorize further, I have 0 is equals to 12x times 1 minus x times 1 plus x, because the difference of two squares. Therefore, I have 3 possible values of x, that is x equal to 0, or x is equal to plus 1, or x is equal to negative 1. So the question said find the maximum area. So I'll test or use these 3 values of x in my original area equation. So when x is equal to 0, the area is 0. That doesn't look like a maximum. When x is equal to 1, I have 6 times 1 squared minus 3 times 1 to the power of 4, which is 3 units squared. And when x is equal to negative 1, I have 6 times negative 1 squared minus 3 times negative 1 to the power of 4, which is also 3 units squared. So therefore, the maximum area of the rectangle is equals to 3 units squared. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.